Hello, my name is Jonas. In this video, I'm going to show how to set up a C9 or CX series OLED for content creation and color grading in HDR. For calibration, we're going to use the Calman Home for LG software and a tri-stimulus probe from X-Rite. Now, if you're anxious to start working in HDR right away, at least follow along during the first part of this video, where I'll start by showing you how to configure the basic settings of your OLED. So let's start by getting the basic TV settings in order. The process of configuring these settings is the same if you're, for example, streaming HDR content, as long as this activates the HDR mode on your TV. In the picture settings menu, start by setting energy saving to off. Then go to additional settings and make sure that eye comfort mode is disabled. Now go back to the main picture settings menu. To get the best possible out-of-the-box accuracy from both the C9 and CX series, you have to select the right picture mode. The most color accurate ones are the Cinema mode and Filmmaker mode. On the CX series, the new Filmmaker mode has replaced the older Technicolor mode, which you can select if you're a C9 user. Both these two modes can also be calibrated. There are also a few settings that you want to look over. To access them, go back to the picture mode settings and start with the Advanced Controls menu, also called Expert Controls. Make sure that Dynamic Contrast, Dynamic Tone Mapping and Super Resolution is all set to off. Leave the color gamut setting to Auto. Finally, set peak brightness to high. Now go into the white balance menu and make sure that the color temperature is set to Warm 2. Go back and select Picture Options and make sure that noise reduction, MPEG noise reduction and smooth gradation is all set to off. Black level should be set to low. Now, if you have a 24 FPS source, the Real Cinema option will also be available. Setting this option to on will provide a 5:5 pull-down by playing back every frame 5 times in 120 Hz, instead of a 3:2 pull-down where one frame is played 2 times and another 3 times to conform to 60 Hz. Which isn't ideal and can result in motion judder. So make sure to set Real Cinema to on when working on a 24 FPS project or watching 24 FPS content. Also make sure that both Motion Eye Care and True Motion is set to off. Now go back one click and select Apply to all inputs if you want the changes to be effective when using this particular picture mode in conjunction with other HDMI inputs or playback sources. Before we're done with the picture settings, there's another setting which I would like you to become aware of. Go back another click to the main picture settings menu and select aspect ratio settings. Now, if you're experiencing that you're not seeing the whole image on your OLED, the just scan option can be the culprit. If I select off, you can see how the picture is slightly cropped. And if I select on or auto, it now shows the full image. I would recommend to set this to on rather than auto, just to be sure that you're always seeing the full image on your display. Lastly, go to General Settings, select AI Service, and make sure all the options are disabled, at least those relating to the picture. On the LG C9, you'll find the AI Picture option in the Picture Mode settings. Make sure it's disabled. Now, there are several reasons why you want to calibrate your OLED. First up is color accuracy. According to Hartings, the CX series OLEDs have great out-of-box color accuracy, much better than the C9 series. So, C9 users should see more improvement in colors compared to factory settings than CX users will. Although, from personal experience, I saw an improvement both in colors and in black level after calibrating my 48-inch CX series OLED. Except for making you feel more confident about your OLED, and that what you see is a correct representation of the grade. We're also going to perform a couple of important tweaks during calibration to make the OLED perform even better, which is the use of a custom white point target and also custom tone curves. A calibrated display is as good as its environment. There's little to no point in calibrating and setting up your OLED if the room you're working with has the wrong lighting or a colored wall behind your OLED. It's also important to have the right amount of ambient light during a coloring session. And there are 3 basic categories of rooms when it comes to ambient light levels: a bright room, a dim room, and a dark room. The bright room can be represented by the normal home viewing environment, the dim room by a color grading suite, and the dark room by the cinema. What we as content creators and colorists are aiming for is the dim room. Now, to achieve a dim room after darkening any windows, you can use a bias light at the back of your OLED to light up the wall behind it. Here I have an LED strip which creates the ambient light I'm after. It has a very high CRI value, which makes sure that it renders light at the D65 standard very accurately. Now of course, if your walls aren't painted in a neutral grey tone, the light won't be reflected properly. So it's imperative that the wall behind your OLED and the whole area in the colorist or content creator's field of view is painted in a neutral grey tone. Now, if you don't have the ability to repaint the entire wall, you can at least put up a wooden board behind your OLED that's painted in some sort of neutral grey tone. How bright or dark it should be is more or less up to personal preference, but the ambient light level also affects how you perceive contrast. Here I've chosen a tapestry with the most neutral color I could find, which quite closely matches my grey card. I also have a 1 meter long Eclipse bias light strip from Medialight that's mounted to the back of my 48-inch CX series OLED. Now, if you find it still too dark to work in the room with only the bias light, you can add additional light sources. And Medialight will be coming out with a dim mode bulb and also a desk lamp. Just make sure that the light you choose has a high CRI value and renders light at the 6500 Kelvin. Personally, I tend to work only with a bias light that's mounted to the back of my OLED. When calibrating a display, you need a device to take measurements of the light emitted by the monitor. I've chosen a tri-stimulus colorimeter from X-Rite, namely the i1 Display Pro Plus. The i1 Pros from X-Rite are very common and used by many for display calibration. The Plus version that I have was released in late 2019 and can take readings up to 2000 nits. If you don't have access to a Pro today, I would recommend this one over the older version, since you probably have a brighter display to calibrate in the not so distant future. I also heard that this newer Plus version is more color accurate out of the box compared to the older one, but that's nothing I can confirm. Now, I should also mention that if you buy an i1 probe directly from Calman, it's a different version than what you'll find at your local retailer, called the OEM version. And since January 2017, the Revision B model of the i1 Pro display OEM also has the ability to take readings up to 2000 nits. Now, to get the best calibration possible, professional calibrators usually profile the less expensive X-Rite probe to the display they're calibrating, using a much more expensive spectroradiometer or spectrophotometer. And here's how Calman describes profiling. For this course, I find profiling to be a bit overkill. Just know that it's possible to achieve even more accurate results by profiling your colorimeter to your display. If that's something you wish to do, I suggest you consult your local calibration expert. So, let's get into the topic of a custom white point target. The thing is that white can appear differently depending on display technology, even with the same white point setting. So, when RGB OLED was introduced, colorists found that the white point had a greenish tone to it compared to displays they were used to work with. This is known as metameric failure. A solution to this was Sony's implementation of the YAD modification, which is an offset that moves the D65 target to a slightly cooler white on the x-axis and from green towards magenta on the y-axis. Now, this modification only regards the white point. All the other targets for the red, green and blue primaries stays the same. It's also worth reiterating that the YAD modification, which is common practice within the industry, is related to the RGB OLED technology, and how we as humans perceive light emitted from those displays. Now, the C9 and CX series OLEDs that we are using utilize another type of OLED technology, called white OLED. And since these displays have entered the post-production facilities, they too need to be perceptually matched to the grading monitor. According to Tyler Pruitt at Portrait Displays, post-production facilities in California working with HDR video uses LG OLEDs in conjunction with more expensive HDR grading monitors. Here, the LG OLEDs are used for client viewing, where the extra display avoids getting crowded on the colorist smaller grading monitor. So the goal for setting up and calibrating the LG OLEDs for these facilities is to perceptually match them to the existing grading monitor, and this is where a new white point target comes in. Now, you don't have to use a custom white point target, that's totally up to you. You can also choose to calibrate to the D65 standard and to a custom one, and then compare the two. So let's get started with the calibration.